Alright, so here's an example of factoring something with an a term not equal to 1. So in this particular example, you'll notice that you have a negative a term. Now we have a couple options here. Something that I generally will do in equation like, or I'm sorry, an expression like this, just because it makes life a little bit easier, and this is something you'll actually be doing with your trigonometric expressions anyway, is to pull that negative out, and what we're going to find is that it actually makes this into a much nicer problem. Now, what I'm basically doing is I'm just factoring out a negative 1. So everything in here is just going to become its opposite. So we get 6a squared plus 25a plus 25. Okay, and a good check whenever you pull something out like this, just because it's really easy to make mistakes, is to go ahead and just multiply it back in and make sure that you can get back to where you were. So negative negative 1 times 6a squared is negative 6a squared. Negative 1 times 25a is negative 25a, and negative 1 times 25 would give us a minus 25 there as well. So we're in good shape as far as that goes. Now we get down here, and what I'm going to do, some of you have learned reverse foiling, but I'm pretty happy with the generic rectangle here, so we're going to go ahead and use that. The big X is going to be the same. Up here in the top, we're just going to take our first term, A, times the C, 25. 6 times 25 is 150. Okay. And then we're going to go ahead and put our B term right down here. Now, in this particular case, then, we are looking for two numbers that multiply to equal 150 and add to equal 25. And let me see, 23 times. And I don't know that those exist. Let's see here. 18. Oh, wow. Okay, so those of you who hung with me probably saw how silly it was that I couldn't think of those. It would obviously be 15 and 10. All right, so now moving on from there, what I like about this is it takes a lot of the guesswork out of it. So in this particular case, we just take our first term, the entire first term, and we're going to plug it right in here into the first box. We take the last term and we plug that right in over here at 25. And then we take these two middle terms and we plug them in here and here, keeping in mind that the 15 and the 10 aren't just 15 and 10, they actually have to add up to the 25a here. So it's 15a and 10a. Now we just look for greatest common factors. We do that piece by piece. So the greatest common factor of 6 and 10 is just 2. And they both share an a, so it's going to be 2a. And then here, they both only share a positive 5. We move to the next piece, and we just need to basically say, okay, this is a rectangle, and I probably should have explained that a little bit more. The area of the rectangle is equal to its length times its width, and that's true of all these small rectangles as well. So if I multiply this length of this smaller rectangle right here times the width, I should get 6a squared. Well, that means that it could be nothing else but 3a. 2a times 5, 2a times 5 will give me 10a, and then I just want to verify the other ones. 3a times 5 will give me 15a, and 5 times 5 is 25. Alright, so now I'm going to keep that negative out in front, and you can leave it there or you can factor it back in if you choose afterward. But filling in my factors, well, the factors are just the length and the width. And again, I made this the area of the rectangle here equal to my original function, or so the length times the width will equal that as well, meaning that I know that 3a plus 5 times 2a plus 5 is in fact equal to 6a squared plus 25a plus 25, but now it's nice and factored out, which is obviously very nice when we try to cancel things out.